You don't need to memorize structure, right? As long as you remember the acetyl-CoA, you will know fatty acyl-CoA. Right? So this is the end product, right? End product. So now this is the free fatty acid, correct? Fatty acid is the R group, COO. Right? It will first form a carboxylic ion over here, right? And ATP comes along to form a fatty acid adenylate and PPI, right? So ATP will be cleaved over here, and then it carries this free fatty acid on its structure, right? This is the fatty acyl adenylate intermediate. Only when it is being carried like that, then CoA can come in to work on the carbonyl group to form the acyl-CoA over here. Alright? On its own, the free fatty acid, the CoA cannot do anything for it. So it needs help from ATP. Right? So the enzyme involved over here and here, did you see it's the same? Fatty acyl-CoA synthetase. Yeah? Fatty acyl-CoA synthetase. It's the same enzyme. Okay? So it just formed an intermediate. And at the end of it, okay, fatty acyl-CoA is being formed. So this fatty acyl-CoA is still not good enough, right? We say that it occurs in the cytosol. Beta oxidation occurs in the mitochondria. So what should we do, right? We need a process, right, to transport it into mitochondria. Again, troublesome matrix, right? The troublesome mitochondrial inner membrane cannot cross. So we need some kind of transport system to move this acyl-CoA, which is our starting point, to become acetyl-CoA, finally become carbon dioxide and water. So now this acyl-CoA crosses the outer membrane, but not inner membrane. Okay? So what do? We get the help of what we call a carnitine molecule, right? It gets bound to a carnitine molecule, and this acyl carnitine will then be transported across the membrane, all right, with the help of a pore, a channel. And the acyl group will then be transferred from carnitine to mitochondrial CoA by carnitine acyl transferase 2. Okay, the picture will show you what this description is. So cytosol is here, right? We have formed the acyl-CoA over here in the cytosol, right? But this cannot cross into matrix. Final destination, all right, is the mitochondria. And then, so we need a way to transport it, and this is facilitated by a carnitine molecule. The carnitine molecule will form an ester bond with the acyl-CoA, regenerating the CoA. So the CoA is removed, okay? And carnitine is over here. This is a carnitine ester. Carnitine ester over here. And then look at this enzyme, carnitine acyl transferase 1, catalyzes this reaction and allows it to diffuse now into the space, intermembrane space. The transporter opens its pore and channel and allows it in finally to the matrix. Okay, so in the matrix, the carnitine then has to be regenerated by carnitine acyl transferase 2. So 1 and 2, right, works in a coordinated fashion. 1 is in the cytosol, 2 is in the matrix. Right, this combined action will then pass on the acyl group to the CoA pool in the matrix. So the difference now is CoA, there's a CoA pool in cytosol and there's a CoA pool in matrix. Two different pools, right? So you can only move the acyl portion across and pass it on to the CoA pool. All right? So you wish life was easier, right? But it isn't because of all these limitations in permeability. All right? It would be so much easier if this thing can just go across. Unfortunately, no. This membrane is too difficult. It's just like the blood-brain barrier in the brain. Right? We have so much trouble with drugs going to the brain. We still do not have a lot of drugs, effective drugs for mental diseases, for Alzheimer's, for Parkinson's, because of the blood-brain barrier. It's so tight. It's so difficult for molecules to go through. So there's a lot of work, right? A lot of research in finding ways to allow drug molecules to go through the brain. Yeah, then all of us will live longer in a more sane version, sane manner. So this is again the same limitation, permeability issue, right? So transporter will go, okay? Finally, to the fun part, beta oxidation. Now, we have fatty acyl-CoA, alright, and we need to break it down at the end to give us acetyl-CoA, and there are 4 enzyme catalyzed reactions to it. It is in the matrix. Okay, we take a 5-minute break. I'll go through the oxidation later.